We have a lot of things to cover, and I want to do some demos, so it's going to be chock full of content and definitely take up the whole hour. Please feel free to ask questions. You can type in questions into the chat window, and I'll stop once or twice during the presentation to answer any questions that come up. So let's get started. The first thing to understand is Couchbase Architecture and a little bit about its history. So Couchbase was an evolution from memcached. So the founders were key contributors to memcached, which was created in 2003 by Brad Fitzpatrick for LiveJournal as a way to speed up, websites and cache queries and things like that. Doing server-side caching and utilize RAM for speeding up of delivery of information. So that was a single server solution and still around today as an open source project. But those key founders of Couchbase actually evolved the memcached product into what was called Membase, which was a persisted key value store. So it was like and distributed. So it was like memcached, except it was distributed across many servers, and also it had persistence. That evolved into what became Couchbase Document Store, which added JSON support and MapReduce indexes, Elasticsearch integration, and cross data center replication. So we've kind of taken the Membase product and added indexing and querying to that, and cross data center replication, and a number of new features. Our feature set keeps growing, but it's good to understand it as an evolution of memcached because a lot of people are also a common upgrade path for applications to swap in Couchbase instead of memcached, and then migrate their current data store to use Couchbase as both caching and data store together. Our core principles of Couchbase are easy scalability. I'll show a demo at the end of how easy I can add machines to a cluster. Consistent high performance, sub-millisecond read and response. You're getting our binary operations is over a socket, is extraordinarily fast. That high throughput is very valuable to lots of our customers and users. Always on 24/365. You don't have to take it down to change or upgrade Couchbase server, add new machines or anything. It's always on. And the flexible data model also is kind of part of that always on. Unlike relational database systems, you can modify schema dynamically on the fly without having to take it down. So Couchbase server is sort of a homogeneous cluster. So that means every machine is running the same software. There are other systems out there where they have different responsibilities and roles of different nodes, but Couchbase is much simpler than that, in that every node is the same, running Couchbase server. So it's made up of two components, the data manager and the cluster manager. The data manager handles all the data operations, the binary operations, storage, and persistence, and the cluster manager is maintaining sort of the health of the cluster, monitoring, communicating with all the nodes in the cluster, and also maintains the sort of configuration of Couchbase. So when you query for the configuration, or when the SDK is querying from the configurations, contacting the cluster manager. And the web UI, the admin UI, is also part of that cluster manager. We, as I said, Couchbase is an evolution from memcached. It actually still supports the memcached protocol and interface. You can use memcached SDKs. Our own Couchbase SDKs are going to perform a bit faster. They're optimized and more efficient for Couchbase, but it's still compatible with memcached. So we still have the 11.2.11 port, and our SDKs actually use the 11.2.10 port. And then those are for the binary operations. And then port 8092 is for our view querying, our index querying, and our administration port is port 8091. The data manager is written in C. It's that's where the RAM cache and the indexing and persistence is all taken care of. And then the server and cluster management is all in Erlang. So Couchbase operates like a key value document store. So if you're familiar with key value, dictionaries, hashes, if you're a programmer, dictionaries and hashes are also key value stores. This is a distributed key value store, and the key can be up to 256 bytes. Values can be simple data types like strings and numbers. It doesn't have to be JSON per se. It can be just straight data, simple data. It can also be binary data. We can also represent complex data types, like arrays, hashes, and lists, etc. They can be stored, in JSON format. So what's very valuable about the JSON format, which is, sort of similar to XML, except much more lightweight and compact, much easier to read, is that you can store simple and complex data types within JSON. It's basically a special class of string with a format, just like XML and HTML is a type of XML. Is just a string, with a specific format. So JSON is a notation for, encoding simple and complex data structures. The schema is unenforced. It's in what we call implicit. It's an implicit schema. So your programming model, your model layer of your application, is creating a schema on its own through its JSON representation. So it's an implicit schema. Couchbase itself doesn't have a mechanism for deciding what the schema will be and enforcing it, which is different than relational databases, where you have to explicitly specify the column types for every table. This the schema in Couchbase can vary from document to document. So documents and metadata. Metadata is the information that we keep track of for every document in Couchbase. Even if the document is just a simple type like a number or a string, there's metadata associated with that. And we're going to call all those values documents, whether they're JSON or they're simple data types. We're just going to call them documents for convenience. So the metadata includes, the key. So it's a key value store. So the key is included there, the type, the expiration, flags and revision numbers are used internally. All the metadata for every document within Couchbase is kept in RAM. It's important because then we can return very quickly when you do a get operation, a retrieval operation, whether that key exists or not. It doesn't have to go to disk to let you know whether it exists or not. This makes operations really fast. Now the value will be kept in RAM. The values for the key value, the values will be kept in RAM whenever possible. It depends on how you configure your Couchbase cluster. If you want all values kept in RAM or most values, for certain instances, like an ad serving network, you're going to want everything in RAM because you never want to hit disk. You have, maybe nanoseconds to deal with, retrieval of information because there's all kinds of decision making that has to take place to display an ad. So the actual retrieval has to be extremely fast. So in that case, they configure their clusters in order to, keep all documents resident in RAM. But the way it works is, the most recent in RAM, not recently used, can get ejected if you are running low on RAM, and we'll see that in a demo later today. And of course, everything is also persisted to disk. So let's kind of look at these retrieval operations. So how does this work? So the application server is doing a GET request, a retrieval. It's hitting Couchbase server, and on the right you see sort of the internals of Couchbase server. It's coming from the RAM cache. And in the storage operation, when you do a storage operation, which is set, add, or replace, it goes to the RAM cache, and then it gets added to disk write queues and replication queues. Then, in both cases, in the disk write queue, it'll get persisted to disk. It's very efficient. It only persists the latest version. So if you're doing 1,000 updates a second per document, per a single document, it's only going to, when it gets to the top of the queue, it's only going to write the latest one. So it's not going to write all 1,000 operations. It'll only write the latest one when it gets to the top of the queue. We don't keep track of versions in Couchbase. For anybody who's coming from CouchDB, we don't have multiple versions in Couchbase. So we are a consistent database, and we don't keep multiple versions. Also, for replication, it'll hit the replication queue and be sent out to another Couchbase machine in the cluster for failover and failsafe. So consistency. So when you do a storage operation, it immediately goes to the RAM cache. It gets added to the disk write queues, but if you read, you're reading your own write. So we're always consistent. So as soon as you've done a write operation, if you do a get, you're going to get that new updated value because it's going to come from the RAM cache. So this is where it's familiar for anyone who's familiar with memcached, which is also consistent. As soon as you do a storage operation, if you do a get or retrieval operation, you're going to see the consistency there, where you're going to read your own write. The eventual consistency model of other NoSQL databases is not the way Couchbase works. Couchbase is a consistent database. So I'll show that animation again. We're doing a storage operation here. It's going into the RAM cache, and if you immediately do a get operation, it's going to come from that RAM cache. And in the meantime, it's also going to those disk write queues and replication queues for persistence and failover and replicas. So what happens when you actually use up your allocated RAM across your cluster for a particular Couchbase bucket? A bucket is a database in Couchbase. What we do actually is when we get to about 90% of your bucket quota of RAM, we look at the not recently used list and begin ejecting it from from RAM. We eject values from RAM, not the metadata and keys, but values from RAM. They get ejected to being on disk, and then when you do a retrieval, they will actually come from disk into the RAM cache and then back to the application server. So in this case, we're doing a get operation on a key that was ejected from RAM and is being pulled off disk into RAM cache and returned back to the application server. So, and this this is not very common. Most of our users and customers actually try to keep a very high residency ratio of values in RAM, not document values in RAM. But this is what happens, just so you understand what happens if you do get up to 90% of your allocated RAM. It'll eject it onto disk, and then when you do a get, it'll pull it back into the RAM cache and return it back to the application server. But from then on, because it's now in the top of the recently used list, it's in RAM cache, and it'll have ejected. If you're still at at 90% or above, it'll eject another not recently used document. So then this is constantly going on if you're at that 90% level. So clients connect directly to Couchbase nodes. There's no nodes. There's no idea of sort of a director node that redirects requests to different shards or whatever. This is each Couchbase, each application server connects directly to Couchbase nodes through a binary socket. So there is a map. So let's talk a little bit about how we distribute our data. So in Couchbase, we have 1024 partitions. That number is sort of arbitrary. It always comes up, well, what about if you want more partitions or less partitions? That's actually less relevant because it's just a certain number of partitions. This turns out to be a pretty good number of partitions, and we've been working with this for many, many years. We have 3 I/O workers, and we have 8 gigs of RAM, set up on this Couchbase server. So there is also a map of the cluster that is within the Couchbase server, and this map, when a application server connects to Couchbase, this map actually has the partitions to Couchbase node mapping within the cluster, and you're going to see in the next animations when we expand this cluster what that means exactly. So it's keeping track of which partitions are on which Couchbase node. So in this case, we only have one Couchbase node, so all 1024 partitions are on this one Couchbase server. What we do in order to distribute data is we hash the key, so key value again. We hash the key, and what we get is, it's a very simple hash. We get a number from 0 to 1023. That's basically the partition that it should live on. And then within the cluster map, we look at that partition number and say, well, which IP address and which Couchbase node is the active master for that partition. In this case, all 1024 are on one node, so all of them are going to end up going to this server. But as you're going to see, when we add another node to the cluster, we're going to redistribute through a rebalance. We're going to push, or move 512 of those partitions over to the next server that we just added. Now what we've done is we're going to update the map. Now there's 512 partitions per node, since there's 2 nodes. where the maps will get updated on the application servers, and now we've doubled our I/O workers and our RAM available. So every node in Couchbase is identical. So when we have 8 gigs configured on this machine, when we add another machine, we're basically doubling and adding another 8 gigs, adding another 3 I/O workers, and we're increasing our. This is our horizontal scaling. We can keep adding these servers horizontally and increasing our capacity of RAM and I/O workers. So I'm gonna double this to 4. And in this case, when I add 2 more servers and rebalance, I'm moving another 512, but it's 256 per node since I'm adding 2 servers, and I'm doubling my capacity again. Now that map gets updated, and then the maps on the client servers get updated as well. So when that rebalance is complete, what happens is the map within the Couchbase cluster gets updated. So partition 0 to 255 live on the top server, and then but it's actually more complex than that. They get redistributed based on a sophisticated algorithm, But basically, what we're looking at is these partitions are evenly distributed. So now, when you have a key and it gets hashed to a partition number, that partition number might live on server 1, or that partition might live on server 2. And when you do a rebalance, there's a map of that partition to Couchbase node that gets updated in the client. The client knows now where to go, and it has connections to all 4 of these nodes in the Couchbase cluster. So it goes directly to each node based on that key hash. And now, in this case, I have 32 gigs of RAM and 12 I/O workers because I have 4 nodes of Couchbase. Of course, if you have more RAM, and then you're gonna have multiples of that as you add nodes to Couchbase. You can also configure up to 8 I/O workers and increase your I/O, your disk I/O capacity as well. So sort of the guidelines for how things work is that RAM is for all your metadata and is your document values as well. Generally speaking, most people like to have for the highest performance, they want to have all their values in RAM as well. So metadata takes 64 bytes plus the length of the key. So if your keys are 32 bytes or 32 characters long, you're adding that 32 bytes to that 64, and that's sort of a way you can calculate your metadata requirements. And then there's the document values. If your average document's about 1K a document, or if it's less or more, then you can kind of estimate, well, how much RAM across the cluster will I need to keep all my values in RAM? We also leave RAM for the OS. If you're using our indexing, that actually uses CPU and it comes off disk. So we actually leave RAM for the OS to use file system cache to increase our disk performance for view querying. And that's also important to know. So CPU is used for document indexing, monitoring, and cross-data center replication. We do have some recommendations, at least 4 cores per node in Couchbase, and add a core per design document, which you can learn in Couchbase 104, what design documents are. If you're new to Couchbase and the indexes, you'll learn more about that in Couchbase 104. And then 1 core for each bucket that's using cross-data center replication. These are general guidelines for CPU. Of course, you can always go much higher than that. We're just talking about sort of minimums here. And then for disk I/O, obviously all documents are persisted to disk, and then all our indexes are also on disk, and we also have append-only disk format, and so we periodically, based on fragmentation, will do online compaction while we're doing operations, while Couchbase server is up. It'll compact and minimize our disk usage through online compaction. Of course, for performance, if you're on Amazon, you're going to want to have multiple, EBS volumes, maybe a RAID 0 striping with multiple EBS volume. High IOPS is also great, for higher performance. So our binary socket operations, if you're using memcached, it's 11 to 11. Our SDKs use 11 to 10. We have get, for retrieving documents, set for storing a document, which overwrites it if it exists. We have add and replace, which give errors or exceptions based on if it exists or doesn't exist. If If it exists already and you do an add, you'll get an exception. If you do a replace and it doesn't exist, you'll get an exception. And then typically I use add and replace more than I use set, because set will always overwrite it whether it exists or not. And then we have increment and decrement for atomic counters, and atomic counters are a very powerful feature in Couchbase, which are used all the time, particularly for things that are financial nature, like even in gaming, you've got your points, etc., or your whatever money you're earning in the game or whatever. Atomic counters are often used for that sort of situation because of the atomicity. That means every operation is executed on Couchbase server in order. It's also used for key value patterns, which you can learn about in Couchbase 103 when we talk about modeling. For optimistic concurrency, we do have a compare and swap operation. We do have a get and lock. We have locking available for pessimistic concurrency. Our view querying is on port 8092 over HTTP, and there's range queries and index key matches and set matches. We've got reduces for aggregates and doing statistics. Again, this is all more Couchbase 104 webinar. And then we have group level and grouping queries. Let's take a quick break and I can answer a few questions.
Thank you, Jasdeep. So we have a question coming in. Does each node store all the metadata or just the keys that stores the value? So do we store the entire metadata or just the keys?
Yeah, we store the entire metadata, and which is the expiration, the type, the revision number and flags, which are used by client SDKs, and the key itself. Yes, for every document we store all that metadata, including the key itself. So it's 64 bytes plus the length of the key.
Perfect. Thank you, Jasdeep. Another question, how many replications can we keep in Couchbase?
You can do up to 3 replicas. Obviously, you have to have enough nodes to have 3 replicas. You can't have 3 replicas and only 2 nodes. Otherwise, the replica will live on the same server. So there's a minimum number of nodes. You can do up to 3 replicas. Typically, people do just 1. Sometimes, if you need a little bit more fail safety, you might do 2. But it also, if the more replicas you have, the more resource requirements you're going to want. You want to increase your resources in terms of RAM as well, because you want the replicas to be resident in RAM as well. So if you're going to have 3 replicas, you're going to also want to increase the resources available per node.
Great, thank you. Let's see another question from Alan. What happens to the partition table if you have more than 1,023 nodes?
That's what always happens. Is most people think in terms of like how many nodes of Couchbase do I need? Well, just to give you an example, like Orbitz, which is a fairly high traffic site, one of the biggest traveling booking sites on the internet in the United States, they have I think two clusters of 30 or 40 nodes. So to give you an example, that's a fairly large cluster. So you're not gonna have 1,000 nodes of Couchbase in a single cluster. I mean, it's gonna be more like, for a very large cluster, 30, 40 nodes, grouped together. And Erlang is pretty chatty as well. So, in general, we recommend not going above 50 nodes in a single cluster. So you can partition your data into multiple clusters. Just because Erlang is so chatty. But Erlang is excellent for a lot of things, but it can be chatty. So that gives you sort of an estimation of traffic for a number of nodes. So you unlike some other NoSQLs like HBase where you might have 2,000 nodes. In Couchbase, generally speaking, you won't have that high of a number. You won't need it because of our performance is so high. You won't need that many nodes. So that's why I was saying the number of partitions is sort of arbitrary. We picked 1024 and it's been working. It's a good distribution as well when you're distributing across 1024 partitions, with the hashing of the key. So it's a nice even distribution, and we've hundreds of customers and we've been doing this for years, so it's actually turned out to be quite good.
Perfect. Thank you. We have more questions, but let's go back to the presentation, and then we can cover more questions at the end.
Okay, great. Thanks. So installing Couchbase. So you can go to couchbase.com/download. We have builds for Ubuntu, Red Hat, CentOS, Windows, and Mac. I do recommend going ahead and using the Enterprise Edition. You do get 2 free nodes. If you're in production, you can do up to 2 nodes for free with the Enterprise Edition. And even on your local machine, there's no reason why you shouldn't use the Enterprise Edition, obviously because it is free up to 2 nodes. And so we can also install via our AMIs, and I'll show you that later as well. If you do on the Amazon Marketplace, if you search for Couchbase, you're going to see 4 different ones. The top 2 here are Enterprise Standard and Enterprise Premium. They include our support contract by default, and you can become familiar with the support contracts first. If you want to do it this way, it actually includes our pricing for support contracts built in. And then we have the Couchbase Server and Sync Gateway. That's for the Couchbase Mobile, Couchbase Lite, and the Sync Gateway, which you can learn about as well. We just had a webinar last week, and we're going to be having webinars soon, regular webinars on Couchbase Mobile coming up. And then, of course, the Couchbase Server Enterprise Free, which I'll demo. And if you want to just set up Couchbase and use it, the Enterprise Free is a great way to get started. Of course, you can download it to your own instance and install it that way. The AMI makes it a little bit more convenient. It's already set up for you. Just making it bigger for you. So Enterprise Free down there, and search for Couchbase in the Marketplace. And I'll show a demo how to do that. When you install the Couchbase, whether on any of these platforms, to finish your setup, you actually browse to, if it's your local machine, it's localhost 8091, or if you use the MI, you put in the public IP and port 8091, you'll see the setup screen. The first step is configuring paths and the maximum RAM available to Couchbase. Available to Couchbase, and that's the important part, is available. So when you get this screen on your local machine, we have a tendency to want to reduce this maximum RAM. Here, let me make it bigger. So, and this is the maximum quota, and I actually highly recommend just leaving that number as is. It won't use that amount of RAM unless you actually fill it with that much data. But if in order to change this value later, you have to use our CLI, our command line interface, to change this value. So it's just much easier if you just leave this value. It is actually tuned to be about 60% of available RAM, to leave RAM for file system OS for MapReduce indexes, for our indexes, our views, which is basically our general recommendation. If you're not going to be using indexing, if you're doing straight key value, then you can increase your per server RAM quota. Now this is the maximum amount of RAM per node. So when you add nodes to Couchbase, this was in my animation when I had 8 gigs per node. This is where I had configured that steps as well. So this is my just storage paths, and this is my maximum RAM for Couchbase. For Couchbase data. So the next step is basically if you want to install one of our sample data sets. The beer sample is correlated with our on our couchbase.com/communities. We'll talk about that in a second, but we have tutorials and getting started related to that beer sample. So if you're new to Couchbase, it's a good sort of sample data set. You can always delete it later or add it later as well. A good sample data set and some applications, tutorial applications that are related to it, so that you would check that box. And then now here is the default bucket. This is like our default database. And this is where you can configure it to use a specific amount of RAM. And this is also per node. So when you add another node to the cluster, it's going to be a multiple of this quota for the bucket itself. So you can have multiple buckets, and it comes out of the maximum RAM available. So here, if you're on your local machine, you can do a couple hundred megabytes or a gig, no problem. Replicas this is where you configure the number of replicas that you want. If you only have one node, like on your local machine, whether it's checked or not doesn't matter. and then you can configure up to 3 replicas. The disk read-write concurrency, that's your I/O. Your disk I/O, you can specify the number of workers, for reading and writing. And then flush is good for development if you want to enable programmatic flush from the SDKs, where you can delete all the data within Couchbase in that bucket. You check it here. We added this to the configuration so that you don't accidentally do that in production. Programmatically delete your data. Your DevOps folks can disable flush so that can't happen in production. And then, of course, your notifications. If you want to add, join our newsletter, this is where you can type it in. You agree to the terms, and then you put in a password and username and password to log into the admin interface. I generally, if you're on your local machine, make this a very simple password. It's not that important on your local machine to have a complex password. I just do ASDF so I don't forget it. If you do forget it, you have to use the CLI to kind of get to the password. And there is a blog post out there for people who forget their password. So I highly recommend just keeping it simple on your local machine. And then your setup is complete. So this is a running Couchbase server now. Those were the final steps of setting up, and we're going to go through this interface and talk about it. So setting up an SDK is also the next step after you set up your Couchbase server. We're going to talk about this quickly, but I talk about it much more in Couchbase 102. We support Java and .NET, PHP, Ruby, Python, C, and Node.js. We do actually have libraries for Go, Erlang, Enclosure, and Tickle, and Perl. They're on our, if you go to couchbase.com/communities, on the left-hand navigation, there's a link for all clients. And if you click on that and scroll down, you can see we have clients for all these other languages. Some of all are, of course, the Couchbase server and all our SDKs are all open source. And one important thing to know for setting up SDK is that PHP, Ruby, Node.js, and Python are wrappers around our C library called libcouchbase. So you have to install libcouchbase first before you install the SDKs for these 4 languages. So you install libcouchbase, then you install, for Ruby you install the Ruby gem, or PHP the couchbase.so, etc. So first you need to install libcouchbase for those 4. The .NET and Java have native SDKs for their languages. So we also have, so for installing libcouchbase, sorry, it's couchbase.com/communities/C/getting started. It gives full instructions for all the platforms on how to install the C library. A few tips for Mac users is make sure you have Xcode and command line tools installed already, because that installs all the C compilers, etc. And then use Homebrew if you're not using it already. Most people do. And make sure you do a brew update and upgrade and doctor to make sure you're up to date before you install the SDKs and before you install libcouchbase. Just a few tips for the people who are new with that. So very easy installation, brew install libcouchbase. Or for PC, for Windows, there's a zip on the website that corresponds to the Windows version and Visual Studio versions that you're using. Red Hat, it basically get the yum repository and then do an install with yum install. Ubuntu, same deal. Get the Ubuntu repository and do your apt-get install. Again, there's full instructions on our website for how to do that. So more on that will be Couchbase 102. I'll be talking about that on Thursday, so feel free to do a register for that, and I'll go into a little bit more detail about all our SDKs, etc. in Couchbase 102 and cover all the operations in Couchbase. So server monitoring. This is always interesting for people. We have one of the best admin UIs of I don't know, to me, of almost all the databases out there. This is an excellent admin UI. So when you look at the sort of cluster, you're going to see when you click on data buckets, click on default, you're going to see a bunch of graphs. If you don't have any operations going, they're all going to be flat, of course. But as you do operations, you're going to see a lot of interesting stuff happening here. These first 2 rows these first two rows, so in this first summary information, these first two rows kind of have an overview of what's going on within Couchbase Server. We have, how many operations per second, you know, how many times we're, our ratio for retrieving off disk if we're having cache miss, like I talked about before, where you've utilized all your RAM and it's pulling it off disk first. It's going to tell you what the ratio is for that. The retrieval operations, the storage operations per second, your deletes, your compare and swap operations, how many of your documents are resident in RAM, what percentage there, and how many total items you have. So very good information there. The next set of graphs is when you are full. If your RAM is completely full and it's ejecting off disk, but your write operations are actually faster than we are able to eject from RAM, you'll get what's called, if you have high velocity writes and your RAM is full, you'll get this temporary out of memory errors, which your client then you handle in your SDKs. You handle that and you retry the operations, and it's based on the amount of memory being used for metadata and data, and then what's called these high and low watermarks. These watermarks are basically out of the available RAM. When we get to the low watermark, we begin ejections and then of replicas. So we're going to maintain replicas within RAM. And once we get to the high watermark, we're going to start ejecting from the active partition, not the replica partition. So these are sort of numbers for understanding when that'll happen. Then we have our sort of disk operations, how many we're creating off of disk, our updates per second, how many times we're reading. That's also related to the cache miss. Our disk write queue size, how many our document size on disk compressed, the doc size on disk uncompressed. The fragmentation, because we use a depend-only format for faster writing. What is the fragmentation level? You can see this sort of pattern here where it's doing compaction and reduces the fragmentation, then the fragmentation goes up, and then it does compaction and reduces it. And then our total disk usage. So if your disk write queue is continually increasing, which might look like this, probably a little bit more jaggy, but like this, where it's continually increasing, this indicates a need for more disk I/O. This might be a reason to add another node to Couchbase to double your disk write capacity by adding a whole other set of I/O workers. So this is one thing to be cognizant of. Is like, okay, I'm actually creating more data than I can get to disk in time, so my disk write queue is building up, and I might need to add another node to the cluster to increase my disk I/O performance. So the partitions, internally we call them vbuckets or virtual buckets. So our partition details is the next sort of group within the admin interface, and it has a lot of different stats here, also related to the partitions. The number of partitions, in this case, just so you know, there's like a little bubble that'll pop up on Mac because of the file descriptor limits that are default on Mac that we don't modify when we install Couchbase Server. We reduce the number of partitions to 64, and I'll talk about why that matters. So all the stats for the active partitions are in that first column, replica partitions. In the second, when you're doing a rebalance, you're going to see stats about things being moved over are pending partitions. Those are the ones that are being moved. And of course, the total information on the right for all of them. So we have the item count, we have the percent resident. It's similar information from that summary, but a little bit more focused on the partitions themselves. How many creations, how many ejections because of RAM is full, the amount of user data in RAM, their documents, and then the amount of metadata in RAM. So all that detail is in there as well. Here's the little note for Mac OS X. So there's 64 partitions, and we do this just to avoid file descriptor limits. And so what's important is XDCR between your Mac laptop and, say, anything on another OS, like anything on Linux or Red Hat, won't work properly because of the difference in the number of partitions. We map partition to partition for cross-data center replication. So just so you understand, don't try and do XDCR between your Mac and another OS. You can actually manually go around this and change things. You have to learn a little bit more about how to configure a Couchbase server yourself, change your file descriptor limits, and then change the configuration, which is definitely possible to do, but I won't talk about it in this webinar. But so just so you understand, if you try and do this XDCR with another OS, you might run into problems. Okay, and then the next section down is your disk queues. You have a little bit more detail. Again, it's by the partitions, active versus replica versus pending. You can kind of see the number of items in the queue, how fast you're filling it, and how fast you're getting it down on disk. And then this last one, if you have good I/O, it's actually, you're not going to see a very high age here. And this is how long it's in, items are, the average length of time that items are in the queue when they get filled before drain. So this kind of tells you also information about how fast your performance is as far as disk I/O. Your fill rate, your drain rate, and your age will kind of let you know whether you have enough disk I/O. So let's do demos. So the first thing I'm going to do is I'm going to do a little load test. I have a little Ruby program here that I made that actually does a number of different ratios. It starts with creating 100,000 items. Then it changes the read and write balance to having a certain percent of read. Actually, it's down here a little bit. I change it. First, it's 100% write, and then it's 33% read, and 66% write, and then it does that again. But it also retrieves more items, and then we go to 60% read and 40% write, and then finally it does 100% read. So it's in 5 phases. But I already dragged the Couchbase server that I had downloaded to my applications. Let's finish the setup here. Oh, I'm not running it. Let's run it. Okay. And I'm going to leave the RAM quota here. Leave all the settings. Those are fine. And I don't need to install the beer sample for this demo. Yeah, I'll put 2 gigs there. I don't need replicas. I do want flush. Okay, set up the default bucket. Since I do demos like crazy, I don't need this information. SDF. All right. And my disk is almost full. That should be fine. All right, I've got a running Couchbase server. And so here's my graphs. Now let's start a demo here. So Ruby load RB. I'm actually going to run, because Ruby is single threaded, there's only so many operations I can generate per thread. So I'm going to run 3 of these in 3 different terminals. So we're increasing our operations here. There we go. Starting to fly up. We're doing 100% creates right now, and this is going to change as it gets it done, gets this load done. So as you can see here, I'm all doing all 100% writes right now. So you can see these are all these sets right here, and I'll give you guys a link to my little simple Ruby load generator. It's really simple. So here, this is the number of operations we're doing per second. These are my disk creates. This is the amount of memory I'm using. Look at the number of items. I think I do about 1 per process that I'm running. I do about 1.6 million operations per. So we're going to do about almost 6 million operations by the time this load test is done. And you can see the number of items is flying up. You can also look at the vbuckets. You're seeing the number of creates, the amount of user data and metadata is increasing, dramatically. Here's my disk queues, my average age. I'm seeing just a tiny bit there, fractions of seconds. I don't even know. 5 decimal places. I'm not really sure exactly what that number is, but it's tiny. You can see my fill rate and drain rates here, the number of items, and it should transition. Okay, now we're in the second phase. Second phase is 33% reads and 66% writes, and the other two are also there since I started about the same time. So you can see here's the proportions here. 1.5 retrievals per second and about 3K, updates per second, or sets, creating data. You can see the fragmentation levels here. If I scroll up, it just did a compaction. You see this fragmentation is increasing because of append only. It's going to hit a configurable threshold, and then you're going to see a notification up here that it's doing the compaction. Once we get to that threshold, we're almost there. There we go. Now we're compacting online. Still doing very high level of operations even during compaction. So this is a good sort of summary. At the same time, what I'm going to do is, while this sort of load test is running, I have a cluster on Amazon, and I don't know how to turn off notifications there, but I have 2 nodes in the cluster, and let me get my, sorry about that. My wife was texting me there. I'm going to add this node here to the cluster. 1 second. Add a server, make sure that IP is not there. Oops, 1053. Yep. Add a node to the. So I have 3 nodes in the cluster. I'm going to add a 4th and a 5th. All right. Let me get the IP of the other one. Oh, did this not come up? I'm doing this through our sort of right scale interface, and it looks like this one didn't come up. So I'm only going to show you just one. Our right scale can be kind of finicky, but we use it for demos and stuff. So I'm basically adding a 4th server to this cluster, and I'm going to do a rebalance, and I'll show you what that looks like. Oh, I don't have a data bucket. Default. Just create that. And I'll show you what that looks like here too. Open up here. Oh, it already did it. So, okay, I'm going to actually remove some nodes and then do it again. It did it too fast. All right, let's remove both ones that end with 9. Yes, I hope that's not the admin interface that I'm actually on. So let's rebalance and remove the 2 there. You can just make sure I'm not on that one. 81. Okay. So I'm actually removing 2 nodes from the cluster, and then I'll add them back in. So while that's rebalancing and removing 2 nodes, I can go back to my local machine. It's still running this test. The load test here, and it's on phase 3, where it's creating 100,000 items, getting 100,000 items, and then updating 100,000 items. And it looks like they're all on that phase. You can kind of see it's plowing through. I can do about one of these per core and get through about on my local machine with just Ruby. The Ruby VM is not particularly fast compared to say Java. Um, I could probably get about so I'm running 3 cores. I could probably get to about I probably use 6 out of my 8 cores and get to maybe 18,000 ops per second on my local machine here. Let's go ahead and install with while we're doing this, I think I can handle installing it on Windows at the same time. Let's see. I'm running Windows just in VMware Windows 7. Doing a lot in parallel here. Let's see. Also, I'll check on this. All right, so I removed 2 nodes from that cluster. It's almost done. And what I'll do is I'll come back to it and add 2 nodes to the cluster and show you the rebalance. So here on Windows, I already downloaded the install, so I'm going to double click it. Yes, that's fine. My computer's doing a lot right now. Let's look back at this. Looks like we're on phase 4. We're 60% read, and you can kind of see the operations here are double the write operations. Still pretty high load, you know, 3 processes running operations. Let's go back to Windows. Okay, so let's finish this install. Of course, I configured this VM to use 4 cores too, so doing pretty good. So I'll let that go ahead and install. Okay, so this rebalance is done. This is on Amazon, and then my final demo is I'll use the AMI and install Couchbase Enterprise Free Edition. All right, so the IP addresses were both ended with 9, so let's put this one in. Okay, adding 1 node to the cluster, and the second one here. Add that server too. This is you can also do all this stuff from the command line. You can script it, and that's kind of what we also do with the right scale. We scripted cluster creation. So in this case, I'm adding 2 more servers to my existing 2 nodes. And when I hit rebalance, it's going to redistribute the partitions, like you saw in that animation. So here we can see that it's begun, and I'll show you it. I'll show you it here. I'm actually going to just pick a particular server. Oops. I keep clicking it twice. Okay, there. Let's pick that node. Right now there's no operations happening because I don't have like any load on this cluster, but I can kind of show you the movement of partitions here. If you look at the vbuckets, that's you know, our internal word for partitions. You can see that they're kind of, you know, this is the new one of the new servers. You can see it's increasing the number of vbuckets that are resident on it. Also the replica vbuckets, replica partitions as well. And you can see, you know, it's doing this rebalance right now. It's probably going to finish relatively quickly because it's these are nice machines and with really good network between them. So it's almost done already. And yeah, almost done there. So basically, that's how easy it is to add nodes to your cluster and increase your capacity and performance. You just add machines. You can add multiple at a time, and then you do a rebalance. And there we go. Now I have 4 machines in my cluster. Very easy scalability is definitely one of the most awesome things about Couchbase. I mean, it's a piece of cake to increase the capacity of your cluster. All right, so then let's go back to Windows and finish the install. Let's do a quick setup. I want to look at my local demo too. It's still going. It's on, still in phase. Oh, no, it's on. Yeah, it's still on phase. Oh, it just started phase 5. So now we're doing 100% reads now. See that? All right, I got Couchbase all over the place. So let's do this Windows machine. Same deal here. I'll just leave the defaults here. Since I only have 1 node, I don't have replicas. So I do this demo all the time. I don't want notifications. There we go. And here we go. So now it's going to come up. There we go. Now I have a Couchbase server on Windows. Works the same way as you saw on Mac. You saw Windows. You saw I did a sort of cluster demo. Here's like 100% reads now. And the last one I want to do, I know we're running a little bit short on time. I want to show you AMI installation. So here I'm going to launch one, do a search for Couchbase. This is the Enterprise Server Free Edition. Let's continue. I'm going to pick a medium on, let's do West, and I'll leave the key pair and all that stuff, and launch that. Okay, so now it's in, launching it. Oops, scrolled too much. And then showing all my subscriptions in my account here. But let's go ahead, exit that. Oh, and then all instances. And this is the one that's initializing. Okay, now it's running, so I can just do running. It's coming up. So this is the one that I did through the AMI. Couchbase Server Enterprise, and then of course I'll wait for it to actually, oh, is it already done? Wow, that's fast. Let's grab that IP. And go to port 8091. It looked like it was still initializing at least the status checks. We'll see if it comes up. I might have to refresh, give it a little bit more time. All right, so Windows is done. Our load test is looks like it's finished on all 3 processes. So kind of got a feel for that. So that was about almost 6 million operations right there. This one probably needs a second to boot up. But now I actually can answer questions while I wait for this AMI to finish getting started there. If we have some questions, that would be great.
Yes, thank you, Jasdeep. I know we are running short on time, but I hope you can stick up and hear some questions. We have a lot of questions. For those that we're not able to cover, we're going to follow up offline, and we're going to have a blog that will cover these questions. So let's start with a general question about Couchbase versus relational database.
Okay.
what's the criteria for choosing Couchbase versus relational database? If you can keep it on a short answer.
Well, one of the main things is performance. So in the early, 2000s, when the internet became more popular, we've been using relational databases for 30 years. Basically since about 1975, so a little over 20, late upper 20 years. And it was the only database. It was the database there were only really relational databases that were popular, at that time. So when the internet was growing, um, we're discovering, as technologists, we were discovering limitations of that technology, and we were having to do things in order to increase performance. Before that time, audiences were really well known in size, but with the internet, you really couldn't know the size of your audience in advance, and so scaling up your applications in the early 2000s was challenging because relational servers weren't really designed for that kind of usage. For unknown or unpredictable loads. And so you started doing things to your relational system, like, first you would try and use replication, but replication's too slow. So then what you do is you shard your data, you distribute it across many instances by using some sort of sharding mechanism. You also, because the most expensive part of querying relational systems is your joins, you'll actually start denormalizing your data so that you reduce the number of joins. And when that started happening in the early 2000s, basically what you were starting to look at was the pre-conditions of NoSQL, where by denormalizing your relational system, you're actually, starting to think like NoSQL databases think, where you're actually creating, sort of like this system that Couchbase is. And so there were some early, NoSQLs in that time, and then evolved, to like our modern day, NoSQL databases like Couchbase, was basically based on that idea of what happens when you need to scale relational systems. So that's a relatively quick answer. It's really performance. If you want high performance, high demand applications, high concurrency rates, Couchbase excels. I mean, that's why gaming companies use us, for online games, and financial institutions, Orbits, etc. They have high performance applications.
Thank you, Jasdeep. So let's go more specific questions.
Okay.
One from Mel. For the larger clusters, so 30 and plus nodes, what would be the recommended partition? If 1024 each node contains 34 partitions, can I change my partition count after I deploy?
That's actually all internal. I actually explain it so everyone understands how we partition our data, but it's not something that you actually tinker with. It's not something that you actually need to tinker with. It's basically, these are just containers in which we use to easily distribute data and redistribute data on a rebalance, but the number of partitions is not relevant. It's not something that you actually need to tinker with. None of our customers actually play with that number or change it in any way. It's just so that you understand how we hash keys and distribute data through a hash. Instead of a range distribution, like range sharding, we do a hash sharding, so we get an even distribution of data across all the numbers of partitions. And then when we do a rebalance, we move partitions over rather than moving, having a map of every document and where every document lives within the Couchbase cluster. All we have to keep track is where every partition lives, which is whole entire collections of documents, and we're moving those around. It's really an abstraction. I hope that helps understand. I think people tend to want to understand how to tinker with partitions, but it's not really something you actually ever need to tinker with.
Thank you. This is a very important concept. We have a question from Rick. How much of an impact does the rebalance operation have on CPU or the disk?
Well, that's an interesting question. It's very hard to give you, like, there's no one answer, because it really depends on, the type and sizes and configuration of your servers. I mean, that's where our support contracts are excellent, to where we can ensure that we give, optimize for your sort of loads of read write, etc., percentages, and all those things. That's where our staff is killer for helping, customers of any size, optimize and be, the most performant way based on your usage. But in general, yes, we prioritize our operations over rebalance. So, we maintain the performance of Couchbase during a rebalance. So rebalance is secondary to primary operations of Couchbase, but it does consume, obviously it does consume resources, and so when you have a high traffic load and your servers may not have a lot of resources or enough resources, maybe you didn't configure it for that, then rebalances can take longer, but that's because we prioritize our operations over rebalance.
Perfect, thank you. So, do clusters need to reside within the same data center, or can they span across different data centers?
So now my AMI is up. Well, that's what cross data center replication is for. Yes, Couchbase cluster generally is within the same data center. I mean, you might have the multiple zones. You could obviously, based on your own strategy, you might have multiple zones within the same region. If we're talking about Amazon, you might have zone A, B, or C, or D in the East's case, where you have Couchbase servers across zones in case a zone goes down. But in terms of regions, that's what cross data center replication is for. You don't want to actually have your cluster be in multiple regions, just zones. And also with development, just as a quick aside, you're not going to connect your local machine, your laptop, to your Couchbase server through the SDK. Our SDKs are tuned to be within the same data center in terms of the timeouts, etc. So you don't actually do operations from your laptop to your Amazon machine in the cloud. You can try and tweak with our timeout settings on our SDKs, because now you're going across the internet for your binary operations, so it's obviously going to be much slower. Our timeouts are not really set up for that. Generally speaking, you would create an API that you would use, so that your application server and your Couchbase server are closer together for network performance.
Thank you. We have time for one additional question, and then we need to wrap up.
Right.
But again, this series is going to repeat every 2 weeks. So not next week, but the following one we will have again Couchbase 101. If you want to reattend and maybe try to see again the demo. Also, we will send the recorded version tomorrow to all the registrants. So one question from Ross. How many nodes can you add or remove in a single rebalance?
I don't know if there's a limit. Actually, one of the things that's actually interesting, when you're upgrading Couchbase, you can do what's called a swap rebalance, where what you do is you remove and add the same number of nodes, and then the new nodes are actually a newer version of Couchbase. So it's called swap rebalance, and actually swap rebalance is really fast, because since you have the same number of machines that you're moving and adding, it doesn't actually recalculate the map. It just actually puts the map back together with the same number of servers. That's called a swap rebalance. But there really isn't a limit. You can add 10 at a time, and you can also script it, of course.
Great, thank you. So Jasdeep will do a blog to answer those questions that we were not able to cover during the session. So at the end of the series, we will have a blog to cover all of those questions. And again, on Thursday, we will have Couchbase 102, and it will be focused on SDK operation. So I hope to see you guys during that session. And again, we have one short survey at the end of this presentation. If you can take 1 minute to respond to the question, it will help us improving this series.
Yeah.
Again,
and anytime you could. Oh, sorry, Franco.
Go ahead.
I was going to say, at any time, feel free to email me or hit me up on Twitter. That's my Twitter handle and my email. If you have questions, I'm more than happy to answer them that way as well.
Perfect. And again, you can also email webinar@couchbase.com for any feedback or question about the presentation, the logistical issues, or anything. Thank you, everyone, for joining us today, and I hope to see you on Thursday at 10 a.m. Thank you.
Thank you.